Have you ever wondered where it all began? The story of our universe is one of the most fascinating tales ever told. It's a story that stretches back billions of years, to a time when everything we know and see today was compressed into an incredibly small space. How our vast universe with all its stars and galaxies came to be? This question has puzzled humanity for centuries. From ancient stargazers to modern astrophysicists, the quest to understand our cosmic origins has driven countless hours of observation and study. Scientists have a name for this beginning, the Big Bang. This monumental event marks the birth of our universe, a moment when time and space as we know them began. The Big Bang theory suggests that the universe started from an extremely hot and dense state, and has been expanding ever since. Imagine a tube, incredibly small, almost unimaginably tiny. This tube is not just any ordinary object. It represents a concept that is central to our understanding of the universe's origins. Now picture this tube containing all the energy of the universe, packed together in a hot, dense soup. This is a mind-boggling idea, but it helps us grasp the immense energy and density that characterized the early universe. This is the idea behind the Big Bang tube, a powerful tool scientists use to understand the universe's birth. In laboratories around the world, researchers are using advanced technology to simulate the conditions of the early universe. By smashing atoms together at incredible speeds inside this tube, scientists recreate conditions similar to the Big Bang. These high-energy collisions allow them to probe the fundamental nature of matter and energy. This allows them to study the fundamental forces and particles that shaped the early universe. Through these experiments, scientists hope to uncover the secrets of how the universe evolved from a hot, dense state to the vast, complex cosmos we see today. Each discovery brings us one step closer to understanding the profound mysteries of our existence. The idea of the Big Bang wasn't always accepted. For centuries, people believed the universe was static and unchanging. However, in the early 20th century, astronomer Edwin Hubble made a groundbreaking discovery. He observed that galaxies were moving away from each other. This suggested that the universe was expanding. If the universe is expanding, it means it must have been smaller in the past. Scientists trace this expansion back to a single point, a moment of incredible heat and density, the Big Bang. The Big Bang tube, also known as a particle accelerator, allows scientists to rewind the clock. This incredible machine is a marvel of modern engineering, stretching for miles underground and housing some of the most advanced technology on the planet. By smashing particles together at nearly the speed of light, they recreate the extreme conditions that existed fractions of a second after the Big Bang. These high-speed collisions are not just random, they are meticulously planned and executed to simulate the birth of our universe. These collisions release enormous amounts of energy, transforming into exotic particles and fundamental forces that governed the early universe. The energy bursts are so intense that they momentarily create conditions similar to those just after the Big Bang, allowing scientists to observe phenomena that are otherwise impossible to study. Think of it like a cosmic car crash. Just as investigators can learn a lot from the debris of a car accident, scientists can learn about the universe by studying the aftermath of these particle collisions. By studying the wreckage, the particles created in the collision, scientists can piece together the fundamental building blocks of the universe. They analyze the data with sophisticated software and cutting-edge technology, looking for patterns and clues that reveal the secrets of the cosmos. This research not only helps us understand the origins of the universe, but also has practical applications in fields like medicine, energy, and material science. The work done here is a testament to human curiosity and our relentless pursuit of knowledge. Inside the Big Bang tube, four fundamental forces are at play: gravity, electromagnetism, the strong force, and the weak force. These forces govern everything in the universe, from the smallest atom to the largest galaxy. By studying these forces in the extreme environment of the Big Bang tube, scientists hope to understand how they interacted in the early universe. This could reveal secrets about the formation of matter, the creation of stars and galaxies, and the evolution of the universe itself. One of the most exciting discoveries made possible by the Big Bang tube is the Higgs boson, often called the God particle. This elusive particle is responsible for giving mass to all other particles. In 2012, scientists at the Large Hadron Collider, the world's largest and most powerful particle accelerator, announced the discovery of the Higgs boson. This groundbreaking achievement confirmed a key prediction of the standard model of particle physics, our best understanding of the fundamental building blocks of matter. The Big Bang should have created equal amounts of matter and antimatter. Antimatter is like the mirror image of matter with the opposite charge. When matter and antimatter meet, they annihilate each other, releasing a burst of energy. However, our universe is made almost entirely of matter. The Big Bang tube helps scientists study the subtle differences between matter and antimatter, hoping to explain why matter prevailed and formed the universe we see today. The Big Bang tube also sheds light on one of the most perplexing mysteries in astronomy: dark matter. Astronomers have observed that galaxies rotate faster than they should based on the visible matter they contain. This suggests that there is an invisible form of matter called dark matter providing extra gravity. The Big Bang tube helps scientists search for particles of dark matter and understand its properties. The Big Bang theory tells us that the universe is expanding. But what is it expanding into? The expansion of the universe is often compared to the inflation of a balloon. As the balloon inflates, the dots on its surface, representing galaxies, move farther apart. However, the balloon analogy has its limits. The universe doesn't have an edge or a center like a balloon. Instead, space itself is stretching, carrying galaxies along with it. The Big Bang left behind a faint afterglow, a sea of radiation called the cosmic microwave background, or CMB. This radiation, discovered in 1964, provides a snapshot of the universe as it was just 380,000 years after the Big Bang. By studying the CMB, scientists can learn about the early universe's conditions, such as its temperature, density, and composition. The Big Bang tube helps refine our understanding of the early universe and how it evolved into the complex structures we see today. The Big Bang tube is not just about smashing particles together, it's about pushing the boundaries of our understanding of the universe and the fundamental laws that govern it. At extremely high energies, the forces of nature may unify, revealing a deeper connection between space and time. Experiments at the Big Bang tube offer a glimpse into this realm of extreme physics, where our current understanding of the universe breaks down. The Big Bang tube is a testament to human curiosity, a marvel of modern science that stands as a beacon of our relentless pursuit of knowledge. It represents our quest to understand the universe and our place in it, a journey that has captivated humanity for centuries. As scientists continue to push the limits of technology, they delve deeper into the mysteries of the cosmos, uncovering secrets that were once thought to be beyond our reach. By exploring the subatomic realm, they are not only expanding our understanding of the universe but also paving the way for innovations that could transform our world. With each passing year, we can expect even more groundbreaking discoveries, as researchers continue to unravel the complexities of the universe. The journey to understand the Big Bang is far from over. Each new experiment, each collision of particles, brings us closer to unraveling the mysteries of the universe's birth and evolution. These collisions, though fleeting, provide invaluable data that help scientists piece together the story of our cosmos, from its fiery beginnings to its current state. The Big Bang tube serves as a portal to the earliest moments of time, offering a glimpse into the fundamental forces that shaped our cosmos. These forces, from gravity to electromagnetism, continue to influence the universe today, guiding the formation of galaxies, stars, and planets. By studying these forces, scientists hope to unlock the secrets of the universe's past, present, and future, providing insights that could one day answer some of humanity's most profound questions. The work being done with the Big Bang tube is not just about understanding the universe, it's about pushing the boundaries of human knowledge and inspiring future generations of scientists and explorers. Through educational outreach and public engagement, the discoveries made here will ignite the imaginations of young minds, encouraging them to dream big and pursue careers in science and technology. The Big Bang tube is also a symbol of international collaboration, bringing together the brightest minds from around the world to work towards a common goal. This spirit of cooperation and shared purpose is essential for tackling the grand challenges of our time, from understanding the universe to addressing global issues like climate change and energy sustainability. As we look to the future, The discoveries made with the Big Bang tube will continue to shape our understanding of the universe and our place within it, guiding us towards a brighter, more informed future. A universe of discoveries awaits, and with each step forward, we come closer to unlocking the secrets of the cosmos and realizing the full potential of human ingenuity.